Ever feel like managing infrastructure is like speaking a different language to every single cloud provider? It gets
Nah.
complicated,
Hey,
right?
absolutely. It's a common headache.
Well, today we're diving deep into Terraform. It's this tool that's really designed to tackle that exact challenge, letting you manage infrastructure as code.
Yep. A single language, so to speak.
Exactly. We've got HashiCorp's official overview here and also some great practical insights from the Terraform book by James Turnbull.
Both excellent sources to get a handle on it.
Our mission today? Pretty simple. We want you to walk away with a solid grasp of what Terraform is all about, why it's become, such a cornerstone for modern infrastructure.
And importantly, without getting totally lost in the weeds, the super technical jargon.
Right. We're aiming for those aha moments where it just clicks.
Sounds like a plan. So where should we start? Maybe what is infrastructure as code?
Good call. It sounds a bit abstract, maybe.
It can, yeah.
Yeah.
But think of it like this. Traditionally, you'd set up servers or networks manually, clicking in a console, typing commands. Very hands-on.
Right, the point and click approach.
Exactly. Infrastructure as code, or IAC, flips that.
Yeah.
It's like writing a blueprint, or maybe a recipe, using code to describe your servers, networks, databases, load balancers.
So you write down what you want.
And Terraform is the tool that reads that description, that code, and actually builds it for you. It handles the low-level stuff like compute instances, storage, networking, but also higher-level things too, like DNS entries or even configuring parts of SaaS applications.
Okay, so it's much more than just servers. It's the whole digital environment described in code. That recipe analogy works well.
Yeah, and like any good recipe, using code brings some massive benefits. HashiCorp sums it up nicely. Terraform lets you build, change, and version infrastructure safely and efficiently.
Safely and efficiently. Those are key words. The version part sounds intriguing too, like software code.
Precisely. Imagine tracking every single change made to your infrastructure setup, just like you do with application code in Git.
Okay, wow.
You have a history. You can see who changed what when. You can roll back to a previous working version if something goes wrong. It totally changes how you think about risk.
Yeah, that's a huge shift from hoping you remember what you clicked last Tuesday. It sounds much more stable, more predictable.
Definitely. And it opens the door to automating testing for your infrastructure, too.
Now, I notice HashiCorp mentions this bigger idea, infrastructure lifecycle management. It sounds like Terraform isn't working in isolation.
That's a great point. Terraform is often seen as like the central piece in a larger ecosystem of tools that HashiCorp offers for managing the entire lifecycle.
Okay, what else is in that picture?
Well, there's Packer, which helps create identical machine images like golden templates for your servers.
Right.
Then there's Nomad for scheduling and running your applications, Waypoint to standardize deployments, and Vagrant for creating consistent development environments.
So a whole suite of tools.
Exactly. And Terraform is often the one that lays the foundation, provisioning and managing the actual servers, networks, and databases that all these other tools in your applications run on.
Got it. The bedrock.
They also talk about security lifecycle management with tools like Vault for secrets management, the API keys, passwords, and Console for service networking and discovery. But yeah, our main focus today is Terraform orchestrating the infrastructure itself.
Okay, so Terraform is like the conductor, making sure all the infrastructure pieces are set up correctly. How does it do that? What are the core concepts we need to understand?
Right, let's break it down. First up is the configuration language. Terraform has its own specific language. It's declarative, meaning you describe the end state you want, not necessarily the step-by-step commands to get there.
Declarative. So I want a server with these specs, not click here, type this.
Exactly. You write these descriptions in configuration files, usually ending in .tf.
Okay, .tf files.
Then you interact with these files using the Terraform CLI, the command line interface. That's the tool you run to tell Terraform to read your files, figure out what it needs doing, and apply the changes.
The command line tool. Got it.
The CLI also manages plugins, which are super important, and something called state. We definitely need to talk about state later. It's key.
Okay, state is on the list.
And just quickly, for folks who prefer coding in languages they already know, like Python or TypeScript, there's also something called CDK for Terraform, or CDKTF.
Oh, interesting. So you don't have to learn the Terraform language.
Right. You can use familiar programming languages to define your infrastructure, and the CDK translates it into Terraform configuration behind the scenes. Gives you more flexibility.
Cool. Okay. You mentioned plugins, and earlier we talked about Terraform handling different cloud providers. Is that where providers come in? Sounds like they're the translators.
You nailed it. Providers are essentially plugins that teach Terraform how to talk to specific APIs. Yeah, the application programming interfaces for services like AWS, Azure, Google Cloud, but also many others, databases, monitoring tools, DNS providers, you name it.
So each provider knows the specific commands for that service.
Exactly. It knows how to create a virtual machine in AWS or a database in Azure or a project in Google Cloud. It translates your Terraform configuration into the specific API calls needed for that platform.
What if you need something really obscure that doesn't have a provider?
Good question. The ecosystem is extensible. Developers can actually write their own custom providers using a plugin development kit if they need to integrate with something bespoke or internal.
Wow, okay. Very flexible. So providers translate. Now, what about modules? The outline mentions them as sound like reusable chunks.
Spot on again. Modules are like prepackaged bundles of Terraform configuration. Think of them as reusable building blocks.
Like Lego bricks for infrastructure.
That's a perfect analogy. Instead of writing the same code to set up, say, a standard network setup every time, you can use a network module.
And that helps with consistency, I bet.
Hugely. Modules promote organization, making your main configuration cleaner. They promote reuse, saving time and effort. And they really help enforce standards and best practices across different projects or teams.
So everyone builds the network the same approved way using the module.
Precisely. It reduces the mental load. Teams can focus on their specific application needs, not reinventing the basic plumbing every time.
Is there a place to find these modules, like an app store?
There is. HashiCorp runs the Terraform module registry. It's a great resource. You can find official modules, modules verified by partners, and a ton of community-contributed modules.
Okay, essential library. How do you use one?
In your Terraform code, you declare that you want to use a module and specify its source. That source could be a path to a local directory if you built it yourself, or, more commonly, it could be a URL to a Git repository like on GitHub, or directly from the Terraform registry itself.
And can you lock it to a specific version? I'd worry about a module updating and breaking my stuff.
Absolutely critical point. Yes, you can and should specify a version. If it's from the registry, you specify the version number. If it's from Git, you can use tags, branch names, or commit hashes using the ref parameter.
Good. That ensures your deployments are predictable.
Essential for stability. You don't want infrastructure builds failing because a module you depend on suddenly changed.
So a module is like a self-contained infrastructure component. What's typically inside one?
Good question. A well-structured module usually contains three main things: input variables, the resources it creates, and outputs.
Okay, variables first. They sound like the customizable knobs for the module.
Exactly. Variables are how you pass parameters into a module or even just your main configuration. They let you customize behavior without hard-coding values directly in the resource definitions.
So instead of writing instance type equals t2.micro everywhere, you use a variable.
Precisely. You define a variable, maybe a called instance type, give it a type like string, maybe add a description explaining what it's for, and potentially a default value.
And what kinds of types can variables be? Just text strings?
Oh no, you can have strings, numbers, booleans, true, false, but also more complex types, like lists, ordered sequences of values and maps, which are key value pairs. Very flexible.
Okay. And how do you actually give these variables their values when you run Terraform?
Terraform offers a few ways, and there's a clear order of precedence.
Okay.
You can use command line flags like davar instance type t3.medium. When you run Terraform apply, that overrides everything else.
Direct override. Got it.
You can create files named, say, terraform.tfrs or anything ending in .auto.tfrs. Terraform automatically loads variables defined in these .tfrs files. You can also specify a specific vars file with the dash-var file flag.
So .tfrs files for storing values.
Yep. Then Terraform can also read values from environment variables in your shell if they're prefixed with TFVR. So TFV instance type t3.medium.
Environment variables too. Lots of options.
And finally, if a variable has a default value defined in the configuration, and you haven't provided a value through any of the other methods, Terraform will use that default.
And if there's no default and you don't provide a value,
Terraform will actually prompt you interactively to enter one during the plan or apply phase.
Ah, okay. And the order is command line beats.tfrs files, which beat environment variables, which beat defaults.
You got it. That precedence is important to understand how values get determined.
Makes sense. Okay, we mentioned resources as being inside modules, but let's define them properly. They're the actual things, right?
Exactly. A resource block in your Terraform configuration represents a piece of infrastructure you want to manage. It could be an AWS EC2 instance, an Azure SQL database, a Google Cloud Storage bucket, a DNS record with Cloudflare, user in Okta, anything Terraform knows how to manage via a provider.
So one resource block equals one infrastructure object.
Pretty much. You declare the desired state of that resource in the block, what type it is, what its settings or properties should be, like the size of the virtual machine or the name of the database.
And Terraform makes it happen.
Terraform talks to the provider talks to the services API, and it works to create, update, or delete the actual infrastructure object to match what you described in your code.
Okay, that clarifies resources. Now, back to that thing you mentioned earlier, state. You said it was crucial. Why?
Ah, yes, state. This is fundamental to how Terraform works. Terraform needs to keep track of the real-world infrastructure it's managing.
Keep track.
It stores this information in a state file. This file essentially maps the resources defined in your configuration to the actual objects that exist in your cloud environment or wherever. It records the IDs and attributes of everything Terraform has created.
So it's like Terraform's memory of what it built.
Exactly. When you run Terraform Plan or Terraform Apply, Terraform reads your configuration files and the current state file. It compares your desired state, the code, with the last known actual state, the state file.
Ah, to see what's different.
Precisely. That comparison allows Terraform to figure out what changes need to be made, what needs to be created, what needs to be updated, what needs to be destroyed.
Okay, so without state, Terraform would be flying blind. It wouldn't know if a server it's supposed to manage already exists.
Correct. State is also critical for collaboration. If multiple people are working on the same infrastructure, they need a shared, up-to-date view of the state. Otherwise, they might try to make conflicting changes.
Which sounds like a recipe for disaster. Where is this state file usually kept?
By default, it's stored locally in a file called terraform.tfstate. But for teams, that's not ideal. Usually, you configure Terraform to use a remote backend, like AWS S3, Azure Blob Storage, or HashiCorp's own HCP Terraform Cloud.
And that keeps it shared and safe.
Yes. Remote backends provide locking, so only one person can apply changes at a time, and they keep the state securely stored and versioned. Understanding state management is absolutely key.
Definitely sounds like it. Okay, so state tracks what's there. What about getting information out? Like if Terraform creates a server, how do I get its IP address? Is that outputs?
Exactly. Outputs are how you expose useful information from your Terraform configuration after it's been applied.
Like the IP address example.
Perfect example. Or maybe the connection string for a database you just created, or the DNS name of a load balancer. You define an output block in your configuration, give it a name, and tell it which resource attributes value you want to expose.
And then Terraform prints that out after it runs apply.
Yep, it shows the output values right there in the terminal. Outputs are also important for passing information between different Terraform configurations or modules.
Okay, cool. So that covers the core building blocks: language, CLI, providers, modules, variables, resources, state, and outputs. Quite a bit there.
It is, but they all fit together logically once you start using them.
Now, you mentioned collaboration and state sharing. How does that work at scale, maybe in a larger company? I saw HCP Terraform and Terraform Enterprise mentioned.
Right. So while you can manage state with things like S3, HashiCorp offers dedicated platforms for teams. HCP Terraform, which used to be called Terraform Cloud, is their hosted SaaS offering.
Hosted by HashiCorp.
Yes. It provides a central place for teams to collaborate. It handles secure remote state storage and locking automatically. It integrates tightly with version control systems like GitHub or GitLab.
So changes in Git can trigger Terraform runs.
Exactly. It provides workspaces to manage different environments like dev, staging, prod, manages access controls with role-based permissions, offers a private registry for sharing your own internal modules.
And it's comprehensive.
And it adds governance features like policy as code using Sentinel or OPA to enforce rules about what kind of infrastructure can be created. It really streamlines the whole workflow for teams.
And Terraform Enterprise, is that just the same thing but self-hosted?
Pretty much. It's for organizations that have stricter requirements, maybe regulatory reasons, that prevent them from using a SaaS platform. They can run the same feature set within their own data centers or private cloud.
Got it. So tools to make Terraform work better for bigger teams and companies.
That's the idea. Collaboration, governance, security, scaling up the benefits of IAC.
Okay, let's switch gears slightly. What's the actual day-to-day workflow look like? What are the main commands you'd run?
The core workflow is actually quite simple and revolves around 3, maybe 4 key commands.
Yeah.
First, whenever you start a new project or pull down existing Terraform code or add a new provider or module, you run Terraform init.
Init, like initialize.
Exactly. This command prepares your working directory. It downloads the necessary provider plugins specified in your configuration, downloads any modules you're using from remote sources, and sets up the backend for your state file. You only need to run it once initially, and then again if you change providers or modules.
Step 1, init it. What's next?
Step 2 is crucial. Terraform plan.
Plan, like see what will happen.
Precisely. This command reads your configuration, checks the current state, and figures out what actions are needed to reach your desired state. It then outputs a detailed execution plan.
What's in the plan?
It tells you exactly what Terraform intends to do, which resources it will create, plus which it will update, and which it will destroy. It shows the specific changes to attributes.
So it's like a dry run, a preview.
Exactly. It doesn't actually change anything. It's your chance to review the intended changes and make sure they look correct before you proceed. Super important safety check.
I can see why. So after plan, if it looks good,
Then you run Terraform apply. This command does the same planning step as the Terraform plan, shows you the plan again, and then asks for your confirmation. If you type yes,
it makes the changes.
it executes the plan. It calls the provider APIs to actually create, update, or delete the infrastructure in the real world. This is the command that makes things happen.
Okay, init, plan, apply. That seems logical. What was the fourth command you mentioned?
Terraform destroy. When you no longer need the infrastructure managed by a particular configuration.
You want to clean it up.
Right. Terraform destroy is the reverse of apply. It figures out all the resources managed by that configuration based on the state file and destroys them. Again, it shows you a plan of what it will destroy and asks for confirmation first.
Another safety net. Good. Init, plan, apply, destroy. The core life cycle.
That's the main loop you'll live in when using Terraform.
Okay. Now, the Terraform book you mentioned earlier dives into some more advanced techniques. Can we touch on a few of those, like counts?
Oh, yeah. James Turnbull's book covers some really useful patterns. Counts are fundamental for managing multiple similar resources without repeating code.
How does that work?
You add a count meta argument to a resource block. For instance, if you need 3 identical web servers, instead of copying the auth-instance resource block 3 times.
You just add count 3.
Exactly. Terraform will then create 3 instances based on that single block definition.
That's neat. How do you refer to the individual instances then, if you need the IP of the second server, for example?
Good question. Terraform provides a count.index variable within the resource block, which gives you the index 0, 1, 2 in case of count is 3. You can use this index in expressions, for example, to give each server a unique name like webcount.index.
Okay.
To refer to all the instances created by count, maybe to pass their IDs to a load balancer, use the splat syntax. It looks like resource type dot resource name dot attribute. So maybe auth-instance.web.id would give you a list of all the web server IDs.
The splat. Got it. That sounds incredibly useful for scaling.
It really is. Saves a ton of repetitive code.
What about conditionals, making decisions in the CAD?
Yeah, another powerful technique. Terraform doesn't have traditional if statements like programming languages, but it supports conditional expressions using the ternary operator.
Ternary, the question mark and colon thing. Condition dot value false.
Yeah, it's the one. You can use this to conditionally set attribute values or even conditionally create resources.
How would you conditionally create a resource?
You can combine the ternary operator with the count argument. For example, you could have count var.isProduction, double 1 pointed bidder. This would create the resource, count 1, only if the isProduction variable is true, otherwise it wouldn't create it. Count is 0.
Clever. So you can have different infrastructure configurations for different environments using the same code base.
Exactly. Very useful for managing differences between dev, staging, and production.
Okay, what about locals? The outline mentioned those.
Local values, or just locals, are like defining temporary variables within your Terraform module or configuration.
Why would you need those? We already have input variables.
Locals are different. They aren't meant to be set by the user from outside. They're used to assign a name to an expression or value that you want to reuse multiple times within that same configuration file or module.
To avoid repetition and make the code cleaner.
Precisely. If you have a complex expression, maybe combining several variables or resource attributes to generate a name tag, you can define it once in a locals block and then just refer to the local name wherever you need it. It makes the main resource blocks much easier to read.
Right. Improves readability and maintainability. Like constants or helper variables in programming.
Good analogy.
The book also mentions provisioning. using EC2 user data as an example. What's that about? Isn't Terraform already provisioning the infrastructure?
That's a great clarification point. Terraform primarily focuses on provisioning the infrastructure resources themselves, creating the virtual machine, setting up the network interface, attaching the disk.
Okay, the hardware setup, basically.
Sort of, yeah, the cloud equivalent.
Mm.
Provisioning, in the context often discussed with Terraform, refers to configuring the software on those resources after they've been created.
Ah, like installing packages or setting up configuration files on the server itself.
Exactly. EC2 user data is a simple way to do this on AWS. You can provide a script, like a shell script, in your Terraform configuration. When AWS launches the EC2 instance Terraform created, it automatically runs that script.
So you can bootstrap the instance with necessary software.
Yep. Install a web server, pull application code, configure settings, basic stuff. Terraform also has provisioner blocks that can integrate with more sophisticated configuration management tools like Ansible, Chef, or Puppet for more complex software setups.
So Terraform creates the box, and provisioners, like user data or Ansible, configure what's inside the box.
That's a good way to think about it. Terraform handles the infrastructure layer. Provisioners handle the software configuration layer on top.
Okay, that distinction makes sense. Now, thinking about putting this all together, the outline mentioned conceptually walking through Figure 3.1 from the book, a simple web app stack. Can you paint a picture of how you'd build that using these concepts, say, in AWS?
Sure. Imagine a typical two-tier setup. A load balancer, distributing traffic to a couple of web server instances inside a private network. First, you'd likely define the network foundation, the VPC, Virtual Private Cloud. You might even use a community VPC module from the registry to handle all the subnets, route tables, internet gateway stuff easily. You'd pass in variables to customize the network address range, for example.
Using a module. Smart.
Inside that VPC, you define security groups, basically firewalls, using auth security group resources. One group for the load balancer, allowing web traffic, port 80443 from the internet, and another for the web servers, allowing traffic only from the load balancer.
Controlling the traffic flow. Makes sense.
Then you define the elastic load balancer, ELB itself, using an ausolb resource, specifying which subnets it should live in and referencing the load balancer security group.
Okay.
Next, the web servers. You'd use an auth instance resource block. Here's where count comes in. You'd set count E2, or however many you need, to get multiple instances.
Right, for redundancy.
You'd use variables, var.instanceType, var.amid, to specify the size and operating system image for the instances. You'd associate them with the web server security group.
Using var prefix for variables.
Yep. And you might use the user data argument within the auth instance resource to pass in a script that installs Apache or Nginx when the instance boots up.
Provisioning the web server software.
Exactly. Finally, you'd configure the load balancer to send traffic to these instances. You'd likely create an ausolb target group resource. And in its attachment configuration, you'd use the splat syntax, authInstance.web.id, to automatically attach all the instances created by the count on your authInstance.web resource.
Ah, connecting the load balancer to the instances dynamically.
Right, and you might have an output block to display the public DNS name of the load balancer once everything is created.
Wow. Okay, even just walking through it conceptually, you can see how modules, variables, counts, resources, security groups, outputs, they all interlink to define the whole application stack.
That's the beauty of it. It's all there in the code, describing the complete picture.
That example snippet in the outline helps too, seeing the resource auth instance web block with count, var, security group reference, and user data. It makes it more concrete.
Yeah, seeing the actual syntax, even a small piece, helps connect the concepts.
And the book also covers managing those modules we talked about, like getting updates.
It does. When you first add a module or clone a project, you run Terraform init, which downloads the module code, often into a hidden .terraform directory.
We mentioned init earlier.
Right. If the module source, like a Git repo or the registry, gets updated later, running Terraform init again might pick up the changes, but often you need to explicitly update. There used to be a Terraform Git command, but now init handles most of it. You might need Terraform init upgrades sometimes.
Okay, so init keeps the local module code in sync.
Yes, based on the version constraints you set in your configuration. The book also walks through the process of taking a module you wrote locally, maybe in a subdirectory, pushing it up to a shared Git repository like GitHub, creating a version tag like v1ton 0.0, and then changing the source argument in your main Terraform configuration to point to that GitHub URL using the ref parameter to specify the v1ton 0.0 tag.
Ah, so promoting a local module to a shared version 1?
Exactly. That's key for sharing modules effectively and ensuring repeatable builds using specific tested versions.
Fantastic. Okay. We have covered a ton of ground here, from the basics of ISC to core Terraform concepts, workflow, collaboration tools, and even some advanced techniques and module management.
We certainly have. Hopefully it's starting to form a clearer picture.
Absolutely. So for you, our listener, the learner tuning in, let's try and distill this. What are the absolute must-remember takeaways about Terraform?
I think the biggest thing is understanding that Terraform lets you manage infrastructure as code. And that core idea unlocks huge benefits. Safety, because you can plan and review changes before applying them. Efficiency, through automation and reusable modules. Collaboration, by treating infrastructure like software code with version control. And consistency, ensuring your environments are built the same way every time.
Safety, efficiency, collaboration, consistency. Got it.
Ultimately, it's about gaining control and understanding over potentially very complex infrastructure, all through descriptive code. It makes the invisible visible and manageable.
That's a great way to put it. This has been incredibly insightful. It really shines a light on why Terraform has become so indispensable in the cloud-native world.
Glad we could explore it.
So here's a final thought for you, the listener, to chew on. Think about your own workflows. How could translating your infrastructure into code change things? Beyond just streamlining operations, what possibilities open up for better versioning, easier team collaboration, maybe even automating compliance checks against your infrastructure code?
Yeah, where could this approach have the biggest impact for you?
Exactly. What part of your current infrastructure management feels manual or error-prone or inconsistent? Maybe that's the place to start exploring. And if you want to learn more, definitely check out the HashiCorp developer website, learn.hashicorp.com, and browse the Terraform module registry. Loads of great stuff there.
Absolutely. Plenty to dig into.
Well, thanks so much for diving deep with us today.
My pleasure.